It is 2 a.m. and your pager is screaming because a single availability zone in US East 1 is having a bad night. Half of the internet is down with it, and your website is just another digital casualty in a data center you don't control. Somewhere else, a founder is staring at a cloud invoice that quietly tripled after a traffic spike nobody warned them about. And right now, a developer is watching their app get pulled offline because a hosting provider decided it violated a policy nobody can quite point to. None of this is hypothetical. It is just a typical Tuesday on the modern web where we rent the internet instead of owning it. For 30 years, hosting a website has meant renting a slice of someone else's computer, usually owned by Amazon, Google, or Microsoft. It is a good deal until it isn't. Until an outage takes you down, a pricing tier changes overnight, or a takedown request deletes your business. The Internet Computer Protocol, or ICP, starts from a different premise. What if the network itself was the computer? Built by the DFINITY Foundation, this World Computer is a decentralized network of independent data centers running a shared protocol. It hosts full back-end logic, front-end assets, and user-facing apps directly at web speed, with no AWS account or credit card required. This isn't a niche crypto curiosity. It is a genuinely different architecture for shipping software that lives forever on the wire. Decentralization for its own sake is a weak pitch, so let's talk about the version that actually matters to a working developer. On ICP, there is no server to SSH into and no S3 bucket to configure. Your entire application runs inside a canister. A canister is a unit of deployment that bundles your compiled code with its own memory, state, and execution environment. It doesn't live on one server. It runs across a subnet of independent nodes that reach consensus on every single state change. When a browser requests your site, it isn't trusting one company's server. It is receiving a response that the whole subnet has cryptographically certified. This means censorship resistance and infrastructure resilience aren't features you configure. They are properties of where the code lives. Then there is the cost. ICP uses a reverse gas model, which is a massive game changer for user experience. On networks like Ethereum, users pay to interact. On ICP, the developer prepays for computation using stable units called cycles. Your visitors interact with your app exactly like a Web 2 product. No wallets, no gas fees, and no friction at all. You top up your canister like a prepaid phone, with predictable costs pegged to compute rather than shifting cloud egress fees. Traditional hosting security is a constant battle of firewalls, WAFs, and praying your team catches the next major exploit in time. On the Internet Computer, much of that threat surface is deleted by the very nature of the architecture. There is no underlying operating system for an attacker to gain shell access to, as canisters run in a sandboxed WebAssembly environment. Requests are handled by boundary nodes and distributed across replicated nodes, making traditional DDoS attacks structurally difficult to execute. Every response is cryptographically signed, so the browser can verify the data hasn't been tampered with by a middleman. You can still ship bad code, but the infrastructure layer that usually requires a security team to defend is already hardened by default. There are two realistic paths onto the world computer, depending on how much of the machinery you want to handle yourself. Path A is Juno, an open source platform that gives you a Firebase-like experience with authentication, storage, and hosting. You spin up a satellite canister in a few clicks, connect your React or Vue project via CLI, and run the deploy command. It even supports GitHub Actions, so a simple git push triggers an automatic on-chain redeploy just like Versal. Path B is the DFINITY SDK, using the DFX toolchain for teams that want direct control over custom Rust or Motoko logic. You scaffold a project, declare your asset canister in a JSON file, and test it on a local replica before touching the mainnet. With one command, your site is served, certified, and replicated globally, reachable at a unique ICP 0.io address. A canister URL is fine for a demo, but production sites need a custom domain, which ICP handles through its boundary nodes. You point your DNS records to the ICP infrastructure and serve a simple verification file from your canister to prove ownership. The network handles the TLS certificates and renewals for you. No more 2 AM pages because an SSL certificate expired. Just remember that identity on ICP is origin-based, so you'll want to configure alternative origins if you use Internet Identity. Traditional hosting optimizes for convenience under a single company's control, making you entirely dependent on their whims. The Internet Computer optimizes for something different, an application that lives on a shared, tamper-evident network. It is built for the developer who is tired of outages, unpredictable invoices, and platforms that can pull the rug without warning. The tooling has matured to the point where deploying your first canister takes less time than it took to watch this video. Don't just rent the cloud. Go put something on the world computer and own your place on the internet. Spin up a Juno satellite this afternoon, or run your first DFX deploy tonight and see what the future of hosting looks like.